let's take a look at another rule, and this rule is the intersect rule. So we'll get some idea of what the goal of the intersect rule is first. So let's assume we've got this rule called intersect. And what we'd like to do is we like to pass in a variable x, and then we're going to pass in two lists. So here's a list A, B, and here's a list B. There's no comma there. Here's a list B, C. All right. So what we'd like to see as a result is that x gets set to the intersection of the first list and the second list. So only the things that are common between those two lists are going to show up. So x equals b. And what else would be common between those two? The other thing that's common to both of those is the empty set. Okay. Now, if we want to think about what conceptually is the algorithm that would make this work, taking advantage of facts and relations and rules, we just spent a decent amount of time talking about the member rule. We wrote a thing to determine if something is a member. So let's remember what that was like. So we had this ability to say member X and some list A, B, C. And what that would do is that would let us figure out, is the thing that's here a member of what is here in this list? So maybe what we could do is we could use member to derive the antecedents for intersect. All right, so we could say that X is in both lists if the following thing is true. 1, X is a member of the first list, and X is a member of the second list. All right. So I'm going to rewrite this intersect rule and say intersect X list 1, list 2, and I'm going to say member X list 1 and member X list 2. So think about what I just said here. I said that X is a member, X represents the intersection of list 1 and list 2. If X is a member of list 1 and X is a member of list 2. Incredibly, if we have member defined and we define this rule, intersection will work. Now, the reason why it works is because of the power of unification and backtracking. So let's do a trace to show that it works. And I find that whenever I start feeling like Prolog is mysterious and magical, when I go through the process of unification and backtracking, it all starts to make sense. All right, So let's do an example that shows this. Intersect, and we're looking at the intersection of X, comma, the list A, B, and the list B, C. All right. So recall that the way that member works is that there are three possibilities for member. Let's go take a look at those for a second. All right. Either we have a relation member XX because X is a member of itself, or we attempt to resolve whether X is a member with head of the list or X is a member with tail of the list. So it's X with itself, attempting to find out that X is a member with the head of the list or X is a member with the tail of the list. Okay. So when we resolve these two antecedents, we're going to be using those three member rules. All right, so we're going to start out with, this is list 1, and this is list 2. All right, so the first thing we're going to try to do is resolve the following. Member with X, A, B. All right, that's taking this antecedent and attempting to resolve it. And we're going to look for cases where this is true. Well, member X with AB, we're just going to apply those three rules of membership. So we're going to say that is if using the first rule, we would say M of A, B, that is X, A, B. That's the first rule. That is true. We know that that's true. Okay. Now, if that is true, is the second antecedent the member of X with list 2, BC, is that true? Well, it turns out that if X is bound to AB, let me just redo this, AB, because that's our X, from this first antecedent, if X is bound to AB, that's going to be false. So this is going to fail. All right, so that was our first attempt, evaluating that first antecedent and doing unification. All right, let's try the second. Let's try the second member rule, which is taking the member of, if we've got X and AB, we can also attempt to do set X to be we would attempt to do the first element of the list. We'd attempt to bound X with A, the head of the list. And in that case, we're going to find we do have a situation where that will work out. And the way it'll work out is that MXA will then become MAA, and that is bound to true. So I got this MXA, I got the A here by extracting the head of the list AB. That's the second member rule. All right, so this is true. Remember, A is a member of A by the first member rule. And now I'm going to compare it with the antecedent, the second member antecedent, and I'm going to say, well, is this true? Is A a member of the list BC? That's false, so that's going to fail. All right, my third option is to do member X, B. All right, because the third member option is to take the tail of the list AB and try to bind X to that. Okay, so this is going to then evolve into member B, which evaluates to true. And then we're going to try that antecedent, member B, C. So just to be clear what we're saying here, we're saying, is the list B a member of the list BC? And the answer to that is no. The only reason why the list B could be a member of the second list is the actual list B would need to be inside of the list. So that's going to be a failure. Okay. So that failed, but this is only the first part of 3 member tests for this particular binding unification of B to X. All right, and so what's the second one? Well, the second one is member the head of the list B and okay, so the member the head of the list, sorry, do this again. Member X with the head of the list. So this is getting rather deep, but we're going to get there eventually. So member of X with the head of the list B, well, that then evolves into member BB. So I just want to show you where this is coming from. The member XB is also true if X is a member of the head of the list, and of course it is, that's true. And now we can check that second antecedent in our intersect and say, well, if X is B, then is this true? B is a member of BC. Now that, we could go through the whole process of redoing all the membership stuff, but I can tell you, and we know this from prior work, that B is definitely a member of the list BC. And so we're going to get one X equals B that's going to work. All right, the final membership test here is a membership test with member, so this is number 3, member of X with the empty list. The empty list is the final option up here, which is the membership of X with the tail of the list. So the tail of the list would be the head B removed, and that's going to leave us with empty list. All right, that's going to evolve into member this, empty list with itself, which is true. And then we're going to say member empty list with the list B, C. And we also know that eventually, if we do this, this particular membership recursively, this is the second antecedent of the intersect, eventually that one will also return that this is a member. And so we'll end up with X empty list. All right. That's quite involved in getting this intersect to work. So all of this work that we were just doing manually underneath the covers is done automatically through backtracking and backtracking and unification in Prolog. I'm trying to think if there's anything else that I wanted to say here. Oh, yeah, it's worth spending a moment talking about both how this membership and how this membership operate, because I just showed you the first rule of member being executed for both of these two, and you might be wondering, well, how does the second rule of membership executed for these two, and the third, right? Because there's a membership that checks the tail of the list and the head of the list. So in this example here, once we've tested member XX, it doesn't make any sense to try to test member X tail of the element, and that's because the tail of A is nothing, so it doesn't matter. And I guess with this one over here, testing the membership here, that it doesn't, you can sort of see visually that testing this membership AB, I'm sorry, that one was okay because that one is true. So it's just this one, membership of XA. Attempting to look at the tail of A, which is in a list, or the head of A, which is in a list, will fail. And so that's why the only thing that we're doing here is testing member AA or member XX. And we see that that's true. But then we can't find that particular X inside the second list for the second antecedent. Okay.